In this episode of Toxicity Test, we're going to look at haematotoxicity. These first three slides are taken from the Canadian Council on Animal Care. In the left column on this slide you can see the conventional test method. Haematotoxicity test for acute neutropenia. It's done in a mouse, and basically you just give the mouse the substance that you want to test, either through inhalation or oral or through injection. Anyway, now we're going to look at the alternative test, which is called the colony forming unit granulocyte macrophage CFU-GM assay. It was validated in the EU in 2006, and it leads to a reduction of animal use. The way it reduces animal use is by not needing to test on a second species. So in the first species, which is usually a mouse, it can be a rat I believe, you work out the maximum tolerated dose and you use this figure to compare the in vitro test with. So like I say, instead of just using two species to test the substance, the chemical or the drug, you use the in vitro test, but you do need this maximum tolerated dose figure from the first test. This third slide just says a little bit more about the CFU-GM assay. It says the test compound is incubated with either murine bone marrow, that's mouse or rat bone marrow, mononuclear cells, or human cord blood marrow nuclear cells. So it can be done with just human blood marrow cells, this particular test. The IC90, that stands for inhibition concentration 90%, is measured because they're looking at the inhibition of cell proliferation in this test. At the bottom it just says reduction for use in place of a second species in the haematotoxicity test for acute neutropenia. It's not a replacement as it relies on the availability of mouse maximum tolerated dose data. This slide from the Alltox website just reiterates basically what was said from the other site, i.e. the Canadian Council for Animal Care. This one reads, the colony forming unit granulocyte macrophage CFU-GM assay has been found to be useful for predicting substances that could cause acute neutropenia, which is a decrease in neutrophils, a type of white blood cell in humans. There are two possible sources of cells for this assay: rat or mouse cells from bone marrow, from their bone marrow, and these are from euthanized mice, or from cryopreserved human cord blood mononuclear cells. So this can be a completely non-animal test. This slide, also from Alltox, just gives a little bit more information about this in vitro test. It says the in vitro CFU-GM assay was validated by the European Centre for the Validation of Alternative Methods in 2006 as a substitute to using a second species such as a dog for regulatory testing. The third paragraph reads, some regulatory schemes require testing on more than one animal species, so the CFU-GM assay will not totally replace animals when haematotoxicity testing is required for a substance, but it can replace one of the species, thereby reducing animal use. The last paragraph just gives a definition of haematotoxicity. It reads, haematotoxicity testing involves testing for potential toxic effects of industrial chemicals, pharmaceuticals and food additives on the blood forming system. Now I'm going to look at the European Centre for the Validation Alternative Methods Haematotox protocol. So that's the protocol for this test that they have outlined for scientists to use. If you look at the second paragraph, you can see the link. The link says the ECVAM/INVITTOX protocol is available for the CFU-GM assay, and that is where we're going next. Here we are then at the protocol. The first line reads, the haematotoxic potential of xenobiotics is determined by the evaluation of the inhibition of CFU-GM growth. So that's what we're looking for, the inhibition of the growth in the medium, I suppose, on the test slide. Because if it is inhibited, then we can assume that if we give it to a human, the human cells will also be inhibited in their growth, which obviously, if they're to do with blood cells, especially white blood cells, it will have a very negative effect on the immune system if they are suppressed by a xenobiotic. So that is basically what we're looking for here. Under the title Objectives and Applications, the first paragraph, if you look along, it says to predict chemical induced myelosuppression. Myelosuppression is the suppression of the ability of the bone marrow to produce blood cells, and it is one of the hematological parameters to be considered for the assessment of haematotoxic potential of chemical compounds of various kinds. It goes on to talk about anti-neoplastic drugs, and these are drugs that are used to treat cancer, and obviously these drugs try to combat the ability of the cells to reproduce. I suppose I shouldn't say really reproduce, but divide. Anyway, these neoplastic drugs work by binding to a part of the cell that's involved in the division of the cell, called turbulin and microtubules, which then inhibit the spinal dynamics, thus block cell division. So this is what the scientists are trying to do here, which is great for treating the cancer, but obviously the side effect is that it treats other cells that divide rapidly as well, i.e. the cells in the bone marrow. So the objective is good and the outcome's pretty good as well. I mean, I would have these drugs, let's put it this way. But obviously some of the side effects are absolutely awful from them, but at least they are combating the cancer. The second paragraph under Objective and Applications, all you have to really know is where it says SOP. That stands for Standard Operating Procedure, and that is really what's being laid out here. This slide talks about the endpoints. It says cell proliferation, inhibition of cell proliferation by colony scoring. So I think we're really having to strike a balance here between, obviously we want the cell proliferation in the cancer to be stopped, however we don't in the bone marrow. So I just think, this test is really, you know, if it stops all cell proliferation, then obviously that is going to be toxic and adverse to the human. You know, I suppose the scientists are trying to strike a balance here in killing the cancer, but you know, not killing the ability of the bone marrow to produce especially white blood cells completely. Otherwise, you know, you're going to be just too vulnerable to infection, etc. For people who care about animals, we don't really want the first. Under experimental systems, it says you can use the bone marrow from mice or rats for this test, or you can use human cord blood mononuclear cells, which I think is a type of stem cell if I remember correctly. But anyway, obviously, you know, like I said earlier in this piece, this test can be done completely with just human cells. You know, it can be a completely non-animal test. Anyway, let's get on to the next slide. The first two paragraphs of this slide and the table, well, I'm not qualified to know whether that's scientific or pseudoscience. It sounds like pseudoscience to me, but anyway, but let's look at test compounds and results summary down the bottom, and it says drugs, anti-neoplastics, which we've mentioned, but antivirals and anti-inflammatories, they would be like the steroids, some of the steroids, which again I rate as absolutely excellent drugs, but we do have to look at some of them because they might have this effect of reducing the immune system by stopping the multiplication of the white blood cells in the bone marrow. And it also says there's some environmental contaminants, pesticides, food additives and other contaminants that also have to be tested. Just as a quick add-on, when I was talking about steroids, obviously they're the anti-inflammatories, the steroids. I take beclomethasone for my asthma, which really keeps it under control. But the other one, antivirals, obviously for AIDS we use antiviral drugs, and they have a habit of suppressing the immune system as well, so we have to test those just to make sure they don't suppress the immune system too much. Okay, anyway, that was just a little add-on. I'm going to go on to the next slide now. I'm just simply going to read out the two paragraphs from this slide, and you can make up your mind whether you think this is science or pseudoscience. I'm going to start at the end of the first line. It reads, in vitro tests for haematotoxicity, pre-validation and validation of colony-forming unit granulocyte macrophage assays for predicting acute neutropenia, which again, remember, is the reduction or the decrease in neutrophils, which is a type of white blood cell, obviously critical for the immune system. Anyway, it goes on, generates an estimate of the human maximum tolerated dose by adjusting an animal maximum tolerated dose from registration toxicology, for example rat, for the intrinsic difference in drug tolerance between the experimental species and humans, and also for the differential sensitivity between CFU-GM from the animal species and the human. This model can be used without knowledge of pharmacokinetic differences across species. Nevertheless, this model should be capable of predicting human exposure levels within fourfold of the interspecies variation in tolerated dose due to differences in clearance rates, and this is sufficient accuracy to contribute to setting permissible exposure limits. This simple model is one that was evaluated during the performance phase of this validation study. The important thing here is differences in clearance rates, the interspecies variation in tolerated dose due to differences in clearance rates. Now that is absolutely crucial. That means the excretion, the E in admare, do rats and mice excrete this substance, the test substance, more quickly? How quickly? Fourfold quickly, fivefold, tenfold more quickly than humans would? How do we know? It's one of those retrospective arguments, in my opinion. Anyway, let's go on to the second paragraph now to see what that says. This paragraph reads, it is important to note that available models predict the human exposure that produces a neutrophil nadir severe enough to be associated with significant clinical risk of infection. That's what we were talking about earlier. Goes on, therefore the predicted value is the maximum tolerated dose of acute exposure. To set safe exposure levels, the PEL, which is the permissible exposure level would be set at some dose level below the predicted maximum tolerated dose, and the scale of the reduction is dependent upon the intended use, if any, of the xenobiotic. There's one fundamental question here. Can you predict the maximum tolerated dose of humans from the maximum tolerated dose seen in mice? Because everything about this test all hinges on whether that is a fact or not a fact. Anyway, let's get on to the next slide. This slide reads, the method has successfully been pre-validated, and the conclusion of this study was that the assay, remember this is the in vitro assay using human blood or mouse bone marrow cells, it says provides adequate performance in terms of colony numbers, potential sensitivity and linearity. The prediction model accurately predicted the actual human maximum tolerated dose values for 5 of the 6 test substances. The second paragraph reads, on the basis of these first results, a further phase concluding the formal validation study was conducted and completed in 2000. Later on it reads, the management team of this European Centre for the Validation Alternative Methods study has concluded that this validation stage, where an additional panel of 20 drugs were tested, confirmed the positive results obtained in the pre-validation phase. The third paragraph goes on, furthermore, in 2006, the European Centre for the Validation Alternative Methods, a scientific advisory committee, unanimously endorsed the CFU-GM assay for predicting acute neutropenia in humans as a substitute to using a second species such as the dog for this purpose. It should be noted that the test relies on the availability of mouse maximum tolerated dose data and is therefore not a full replacement method, but is intended to reduce the overall numbers of animals needed in toxicity testing. So there you have it. It's all being compared to the first test, which is done with mice. If that test is wrong, if that test is not predictive, then the second test is useless. This last slide just talks about how you go about getting your bone marrow cells from your mouse. It reads, sacrifice the animals by cervical dislocation without anesthesia. What this means is that you break the neck of the animal and then go about removing the cells. So that's just a little bit of the reality that the mouse has to go through. Anyway, I'm going to go on now to look at a paper that's been written about this assay. This slide shows a paper entitled Risk Assessment of Human Haematotoxicity of Anti-Cancer Drugs, a Predictive Model and the In Vitro Colony Forming Unit Granulocyte Macrophage CFU-GM assay, and it's by a N. Matsubuchi, who is from Japan. This slide shows the paper's abstract. It reads, myelotoxicity is one of the major limitations to the use of anti-cancer drugs. It is desirable to evaluate human myelotoxicity before a phase 1 study. However, this is difficult because of the differences in susceptibility between humans and animals. The purpose of this study was to establish a reliable method to predict the human maximum tolerated dose of 5 camptothecin derivatives. The myelotoxicity of camptothecin derivatives was evaluated on bone marrow from mice, dogs and humans using a 14-day colony forming unit granulocyte macrophage CFU-GM assay to determine the 50%, 75% and 90% inhibitory concentration values IC50, IC75 and IC90 respectively. At this point I was getting quite excited, but then it goes on, then using human and murine, which we know are rat or mice bone marrow cells, values for, so he's automatically brought in animal data here, so I completely lost interest, but we'll carry on. Values for myeliotoxicity of these compounds. In vivo toxicological data was used. He doesn't really specify whether that was from the mice or if that's from retrospective human data, i.e. is the in vivo data human or is the in vivo data another animal? He doesn't say. And pharmacokinetic parameters. And then he goes on, human maximum tolerated doses were predicted retrospectively. You can read the rest of the paper in your own time, but the important thing was, at least this is a scientific paper that recognises that there are differences in susceptibility between humans and animals as regards substances that may cause problems to the white blood cell production in the bone marrow. What else do I need to say about this? Just to say it's a real shame he brought the animal data in, because it would be really interesting to see if we could just look at the human data in the blood marrow test, the CFU-GM test, the in vitro test, but just with human blood marrow, to see if this is more accurate than bringing in other data from animals and then using estimates and so-called expert opinion.